This is a candidate elimination algorithm, and let's look at an algorithm. So this is algorithm. The first part, initialize D to the set of maximally general hypothesis in H. We have solved an example using candidate elimination algorithm. And now let us initialize G with a set of maximally general hypothesis in H. So this is G, which is initialized with the values that is most generic. So the representation of generic is shown here. So these are the representation of generic. So the question mark represents the generic value. And now initialize S to the set of maximally specific hypothesis in H. So S becomes the null is specific and it is more specific. So we have initialized that. And now if D is positive, example, then remove G from any hypothesis inconsistent with D. While solving an example, we have come across where G is having inconsistent with D. So this is an example, the fourth positive example. So wherein, so G3 is with all hypothesis with same here. And now when this fourth instance comes, so this change makes positive since this is same and this is change and it becomes generic. So the same is made generic. So the remains with the only two hypotheses, the sunny any values and warm any value. So this is changed to the new value. So that is what it's telling. Remove G for any hypothesis that is inconsistent with D if it is positive, if D is positive. Yes, it represents the D is positive, this is positive, and G3 to G4. And next is for hypothesis yes in S that it is not consistent with the D, remove S from S. So you have S naught is the null all null value and this is inconsistent and it is replaced by S1. It is replaced by S1. So now the first training example is presented. So S naught is more specific. So it is made more general to S1. So S naught to S1. So you add S to all minimum generalization H of S such that, add S, remove S, that is null, all with null, remove that and then add S1. And the Sn all minimum generalization represents these values: sunny, warm, normal, strong, warm and same. So now H is consistent with D, yes. S3 is consistent with D and some member G in the is more general than H. Remove S, remove from S and hypothesis that is more general than any other hypothesis in S. If D is negative, that is the next part. If D is negative, that is D is a negative example. So remove S, any hypothesis inconsistent with D. So that is what? Inconsistent with D, and for each hypothesis G, each G that is not consistent with D. So that is this part. So if it is the third one, then it is not positive and it is negative, and the third one, and the work is with the conversion of G2 to G3. That means G2 is generic and it is converted to G3. So that is this sunny any value, warm any value and same. So this becomes more specific. So from generic to little bit more specific because it is negative. Now this is the algorithm of candidate elimination algorithm, and when it is positive, we know we showed an example of how the values has to be changed, and when it is negative how G has to be changed, when it is positive how S has to be changed, and both when if it is positive G is changed and as well as S is changed.